Okay, ladies and gentlemen, welcome. This is officially the demonstration that goes with Stemscopes, heat and matter. It's called the investigative phenomenon, and I made this video for anyone that might have missed it live. You can see on the left is approximately a liter of hot water, and a liter of cold water is on the right. I've put some ice cubes in it. They've melted. I'll get some temperature readings for you if you want to write those down. That would be a good thing to do. This is the before. There's a before, a during, and an after, I believe, on your handout. The before reading for hot is, I'm just going to give you a temperature readout. It's 56 degrees Celsius. So that's a capital C, 56. You might be able to pick that up on the camera. On the other hand, the cold water bath is about 9 degrees, well, let's say 10. Nice rounded number. It's just between 9 and 10, closer to 10. So we're going to round up. 10 degrees Celsius for cold, as we'll just let those go. I actually have a digital thermometer. I can compare those. We got 57 as a reading here through the water. It's a little tricky to actually capture that because it's just going right straight through. It says 57 there, and it says 10. So that's pretty accurate. We've got a confirmation with our digital device. There's a clock or watch here just in case we want to keep track of time. What I'm going to do is just drop 1 or 2 drops each into each tub, if you will, each beaker, and we'll see what happens. I'll start with cold. Whoops, don't want to be stirring anything right now. We'll just let that calm down. Okay, here we go. 1, 2. And we'll get this one in right away. 1, 2. We're just looking to see the dye indicates molecular movement. There's a little hint. It's hard to see molecular movement in water itself. The dye helps illustrate that. I'm going to go ahead and wipe off the cold beaker so we can get a little peek through and look at some of the patterns that are emerging here, and we'll give a little close-up. So we're about a minute into the experiment. If you see which one gives us a better view. The hot water bath is almost completely mixed. I think what I'll do is kind of venture out here and take close-up shots of each. I'm going to take this off the tripod, so I'll be right back with you. Okay, this is Mr. Moore back freestyle with the iPad in my hand, and we can see in the hot water bath the dye is almost completely mixed. We're about 2 minutes in, and when you look straight down in here, it's a pretty equal distribution of dye throughout the red food coloring. On the other hand, you can see pockets, especially when I get into the side view, and I'll have to clean this off again, but there are huge areas where the dye has not reached. Let me get my towel. So you can see in there, the dye is kind of clumping up and creeping around into certain areas. I'm going to dry this off one more time. This is called condensation. We're going to learn more about that coming up. If we peek into the bottom of this thing, you can see the dye is just raining down in kind of these little trickles, if you will, and puddling up at the bottom, but not really circulating back up. So that's the main phenomenon that we want to see, the unequal mixing of dye between hot and cold water. There's no other physical stirring of the two waters beforehand. It's just a temperature difference between them. And that is the investigative phenomenon for the heat and matter